First, make a file. Call it whatever you like. We're going to use this file for Cherry AI to use as an extra resource when loading heuristics. In other words, this is where we can store additionally added heuristics. The syntax for declaring a heuristic in Cherry AI is very simple. We simply include the return type and open up a pair of parentheses to include the extra data. For this example, we're going to use the saying, "The enemy of my enemy is my friend." We're not going to actually use this heuristic. This is just a rough idea of what the end result will look like if our program works successfully. First, we'll include a local source variable. It's going to reference the speaker. The source variable is going to access the speaker's enemy relationship, and it's going to return the source's enemy. Finally, it will establish a friendship relationship between the two. Next, we're going to pretend like we have all the time in the world and nothing else important to be doing. The program's grammar system wasn't entirely ready for the example I had in mind, so I had to tweak it a little bit for the presentation. Declare the return type we'll be using for the heuristic, and declare the source variable as, in this case, an end-touch possessive, which is a type I created specifically for understanding grammar. It appears the type of relationship I established earlier to access a possessive noun's noun object is the noun-object relation. We link data that was originally linked to another piece of data using a new type of relationship. Now we incorporate this into the pre-existing framework for describing a noun. The possessive relationship, regardless of how long or wordy or lengthy it may be, will now display within the noun's description. In this example, the program fails to identify the pronoun me with the speaker of the sentence. This is because the program is currently set to assume all nouns are common nouns and not referencing another sort of variable. In this case, the variable it invented upon which it may later include other data is called miekek. I mentioned earlier that my relation-creating heuristic would always form a relationship with a literal thing, so now it's time to change this. Instead of making thing a direct reference in the code, let's instead make it a local value. I'm going to change this to a reference of an earlier described relationship. Once again, the program is currently set to assume all nouns as being common. So for the pronoun my, the program registers a noun under the username anan isul. Let's run the program again. The word my is the fourth word in the sentence. This time it registers the fourth word my as a non-veggie. Here it includes the data of a non-veggie and what it refers to in order to later be used when uncompiling it. It generates the following. It describes ichauf as enemy, and it describes veggie's relationship with the enemy to be ichauf. Veggie's enemy is therefore ichauf. I'm going to fast forward and create some data to demonstrate the program's utility. For this example, let's declare Fluffle's enemy to be Sniffles. Let's also declare Sniffle's enemy to be Fluffles. Let's not include any reference to any friend of any kind. Also, for the sake of this example, let's be sure to list Fluffles as a cat. Let's create a new heuristic that returns friendship. This heuristic will search for a cat and then return the enemy of the enemy. The program returns Sniffles' enemy of Kerplopples, but this isn't quite what we wanted. I'll adjust the syntax to strictly reference Fluffles. Now the program predicts that Kerplopples is Fluffles' friend. Yes, I did cheat a little bit in this example because the generated output here does not look like the heuristic I wrote here. In fact, I'm providing a heuristic that the program did not itself generate. My reasoning for this is because I am extremely busy right now, and the next step required to achieve this is fairly small potatoes. What we do is we take the object to the verb, the type that is being declared, in this case friend, and we set that to the return type of a new heuristic we generate. Now we take all the complicated relationships and we form that together as the heuristics data, And voila, it really shouldn't be hard to translate. It's really no difficult task to convert, I just simply don't have the time to do it right now. I will in fact have significantly more time in the spring semester, so the program's going to advance by leaps and bounds that time of the year. Anyway, this has been a quick clarification. Hope you enjoyed.